In this video, we are going to talk about mathematics, grade 8, and we're going to begin with numbers. And in numbers, we have a substrand called integers. So we are going to talk about integers in the whole of this video, and in the preceding videos, we are also going to do examples on how to solve integers problems. What is an integer? Turns out that an integer is a positive or a negative number including 0. Any positive or negative whole number including 0 are all what we call integers. So an integer is a whole. So 0 is also considered to be an integer. So we're going to look at some of the examples of integers that we have. Remember, integers run from negative infinity to positive infinity. We have so many of them and we can't finish them. So the first example, I'm going to take any negative number. Negative 3 can be negative 2, negative 4, negative 1,000,000, negative 5,000. Any negative number is an integer as long as it has to be a whole number. Now, the second example, we're going to take any positive integer, that is maybe 2, 5, 6, 8, 12, 1,000, 5,000, and so on. Any number that is positive, as long as it's a whole number, is what we call an integer. So the third example, we're going to take a 0. So 0 is considered to be an integer. 0 is the center of negative and positive numbers. So when we're going to get to a point of drawing a number line, we're going to see that 0 is the center. Any random example, like maybe it can be a negative 20 or any positive, let's say positive 100, all those. So this is just to show you that we have unlimited number of integers that exist. So these are not integers. So I have decided to give you examples of those numbers that are considered not to be integers so that you don't get confused. So the first number that is not an integer is any fraction. For example, 1/3. So this is considered to be a fraction and not an integer. Remember, when you talk about types of numbers, we consider fraction as a different type of numbers and integers as different types of numbers. So a fraction is not an integer. And the second number that we may consider not an integer is any decimal number. For example, 3.421. 3.421 is a decimal number, and therefore it is considered not to be an integer. Now, the third number that is considered not to be an integer is any sad number. For example, √3, √5, √11. All those sads, they are considered not to be integers because they are irrational numbers. So the last one is any constant. For example, pi. Remember, pi is an improper fraction, 22/7, or if converted to a decimal can be 3.142. And that is also considered not to be an integer. So the first part shows you the example of integers, and we have seen all of them. There are so many. And in the second part, it tells us the numbers that are considered not to be integers. So that is the introduction part of integers. And in this second part, I want us to talk about number line. So what is a number line? Our first question is, what is a number line? Well, it turns out that a number line is a scale. So there's a scale that we use in mathematics, and to be specific on integers, to be able to understand how we can operate with these integers. So a number line is a scale, first of all, that has the positive side and the negative side, including 0, which is the center. Now, one very important thing that you have to know about a number line is that the portions have to be equal. So when you draw a number line, you must make sure that the portions are equal. So I'm going to draw a simple number line here so that we can demonstrate what a number line looks like. So that is a line. Now this is the center, 0. I'm going to have equal portions. You can use a ruler if you want to be sure that the portions are equal. And if they are not equal, then that is not a number line, because a number line must have equal portions. and to the left I can have also equal portions. And if this is 0, then the next one is going to be 1, 2, 3, and so on. That is to the right. To the right we have positive numbers, and to the left we have negative numbers, and therefore this is going to be -1, -2, -3, and so on. Now, for you to show that indeed that this number line has no limit, you have to use the arrows. So if you don't use arrows here, then you're telling us that this is the end of your number line, which is not the case. And therefore, always as you draw a number line, make sure that it has arrows at the end, just to show that it has unlimited numbers as you move to the right and as you move to the left. So one very important thing that you also need to know about a number line is that this is the one that we use to do operations. The next part, we're going to do the operation on number lines, and we're going to notice that this becomes very, very important when we're doing some operations on number line. So before we get to the operation on number line, I would want us to first of all talk about the rules of signs, the rules of signs of number line in operations. So the signs of mathematics, you understand there are 4 signs, and they include multiplication, subtraction, division, and addition. So these 4 signs are very important when it comes to a number line. If you want to understand on how to do operations on number line, therefore you must know the 4 rules. And therefore, the first rule is the rule of product, or the product rule. So it turns out that if you take a plus, you multiply by a plus, the answer is going to be a plus. That is multiplication. Also, a plus, you multiply by a minus, then the result is going to be a minus. If you take a minus, you multiply it by a plus. See, this is the opposite of this. Again, you're going to have a minus. But if you take a minus, you multiply by a minus, you're going to get a plus. Very interesting here. So we have a plus multiplied by a plus, you get a plus. And then we have a plus, you multiply by a minus, you get a minus. Then the opposite of that is you multiply a minus and plus, you get a minus. And then the end is you multiply a minus and a minus, you get a plus. Something very interesting is coming out here, that those signs that are the same gives you a positive. So minus, you multiply by a minus, you get a positive. And also a plus, multiply by a plus, you get a positive. And also you notice something, that a plus and a minus and a plus gives you a negative. And therefore we're going to conclude something here, that NB, that like signs gives a positive, and unlike signs gives a negative. So those that are unlike, they give a negative, and those that are like, they give positive. So that is the rules of signs, and having understood the rules of signs, then we are ready to work out some few operations on number line. So use a number line to solve the following. So we have A, B, C, and D. So let's use this number line to show how we can solve some problems involving a number line. So the first one is 2 plus 3. Now, I know you understand that 2 plus 3 is 5, simply from your basic mathematics. But you see, in integers, you have to show that from the number line. You have to show how you came up with the result. If 2 plus 3 is 5, then how did you come up with the result? And therefore, so I have drawn a simple number line here. So this is 2, 3, 4, 5, 6, 7. I have a pro tip here, is that, you know, a number line must not show 0 or negative number. You can only draw a number line in a section where you need it, as long as it is consistent. For example, I began from 2, and because I needed anything to the right, and therefore the intervals from 2 are 3, 4, 5, 6, 7, and so on. And you notice that in my number line, I also showed that it can continue to the left and it can continue to the right. So it's important that you know that it's not a must that you have a number line that shows from 0. You can have a number line in any section that you want, as long as it is consistent and the portions are equal, or the portions have equal intervals. That is very important when it comes to a number line. So this one, the way to do it, we're going to look at the first number. The first number is 2, so I'm going to begin from 2. If I begin from 2, because this is a plus, and if I move to the right of my number line, it shows I am, I am going towards a positive direction. So if I start from 2 here, and this is a plus, it means it tells me I'm going to move to the right. How many times? 3 times. So let's see what will happen. So I begin from 2, plus means 3 times to the right, and that is going to be 1, 2, 3. This is where I end, and therefore it shows this is the result of 2 plus 3, and therefore the answer is 5. So as we guessed earlier, the result becomes 5 from the number line. A bit confusing, but let's look at the second example. In the second example, again, we have 5 minus 3. Again, I have drawn a number line based on the operation that I have. So I realize that my number line must have a 6, must have a 5, must have a 3. At least that is the operation that I need to do. So because we said you look at the first number, so the first number is 5. So I'll come here at 5, and then minus means I have to move to the left. Minus means I need to move to the left side of my number line. How many times? 3 times. So from 5, I move 3 times to the left. So let's go. 1, 2, 3. Yes. So this is the result of 5 minus 3. I know you knew from before, because from your calculator or from your basic mathematics, 5 minus 3 is 2. But again, you have to show that in a number line. So if I don't see this, then if it's an exam setting, then you don't score. So the result for that is 5 minus 3. The result is 2. So the third example is a bit interesting. 10 plus, there's a bracket here, minus 3, close the bracket. So what does that mean? Now that takes us to the rules of signs that we have already done. You must make sure that you have a single sign, just like we have a minus, just like we have a plus here. So you have to make sure that we have a single sign. So in this case, I must make sure that this is a 10. Now, which sign am I going to use? Because I have 2 signs, plus and a minus. Remember, in basic mathematics, a bracket means multiplication. And therefore, if I come here, a plus multiplied by a minus, because I said unlike signs gives me a minus. And again, if I look at this is a minus and a plus multiplied, I get a minus, and therefore plus multiplied by a minus, I get a minus 3. So you notice we already have a single sign, that is the one that we are going to use. So this is 10 minus 3. So I'm going to 10. And then from 10, because this is a minus, then we have agreed that in a number line, when you move to the left, it means a minus. Or when you see a minus, then you're going to move to the left. How many times? 3 times. So let's see what will happen. So I'm going to move 1, 2, 3. 3 times. And the result is 7. So the answer becomes 7. So 10 plus minus 3 is 7. So the last problem, I believe you can guess. It's very easy. I'll give you 5 seconds to brainstorm. Yes, as you may have guessed, 20. Now, the sign, as you may guess, is, you see, this is a minus, and like signs gives you a positive, and that is plus 4. Yeah, there we go. And you see, I'm going to 20. Now, because these are plus, I'm going to move to the right. How many times? 4 times. So let's see what will happen. 1, 2, 3, 4. There we go. So this becomes the result. So the answer for that is 24. So that's how easy we can solve problems involving integers. And in our next video, we can do more examples on integers so that you understand on how to use the number line, especially this kind of problems that needs you to use the rules of signs. But remember also, the rules of signs can apply in many other things like fractions and also decimals. Basic mathematics on numbers you have to understand these rules of science. It's like board maths. You see, you have to know that rule for you to be able to do any operations on numbers. That's it for this substrand. Remember to like this video, subscribe, and also leave a comment on what you think about a number line.